Hello, Sascha.
Hi. Hi, Anders.
Hello, hello. So this is your last presentation for the week.
Yeah.
But the subject is really interesting.
It's really interesting.
Graphene. We've heard about it a lot, but now, you know, it's interesting to see where we are. So I'm really curious to hear what you found.
Yeah. So the reason why I talk about this is because last year someone came up to me and asked, oh, you have a lot of innovation, but do you have something based on graphene? And I was like, okay, I've heard about that last, I don't know, 5 years, but it didn't show up. But in this year and last year, obviously we have a change in that. Probably you have heard about the foldable phone. Have you? Did you? Apple is working on this, Samsung is working on this, and it was presented last week by a company called Ruyu, Chinese company. They have presented it 2 days before Samsung did. But they presented a real product, and Samsung just showed some images about what they're going to have. So you can find a video in the internet, which I didn't show because it was Chinese and it was a little bit difficult to understand. So the idea is, why is it not possible to turn an iPad or a larger screen into something which is as big as a phone? It's not about wrapping a phone to something really small. It's more about changing a bigger screen into something smaller. And probably they use graphene. It was not written there, but it's the only technology which we can imagine that they have used for this product. Graphene is a stable form of carbon atoms in a molecular structure. We know diamond, we know graphite, which is some different layers. We know lonstellite, which is a special mineral. We know buckyballs, which came up early 90s. The guy who found out a way to produce the buckyballs, very strong and stiff, got a Nobel Prize for this. Probably you have heard about carbon nanotubes, which is a form of buckyballs without the 5-edged structure. So you have a tube, a rolled one, with a high tear resistance, stronger than any metal you have on the market, conductive qualities higher than these of copper. And we have graphene, which is just one layer, and the guys, one layer of carbon, just one atomic layer. And because there is an interaction between the different layers of carbon in graphite, for example, between the electrodes in the layer, because we don't have not another layer, these electrons are free to move. And they can move with light speed. That's why graphene is conductive for heat and conductive for electricity in a very, very good way. So it could be used in the computer industry, it could be used for electrodes in OLEDs, could be used for batteries in the future. So that's all coming up probably this year or the next years. What is on the market, what came onto the market is a bicycle, because it's also strong and has very, very good mechanical properties, is a bicycle frame made of one single layer that is add to a normal normal carbon bicycle frame to make it stronger and lightweight. This came up in 2016 by a company called Dassi from the UK. They say it's that the frame is 30% lighter than other carbon frames. I don't know who needs this, but I mean, carbon frame is just unbelievable light, but okay, maybe it's 4 kilograms just the frame. We tried to get this for our exhibition, but they didn't send us the bicycle, so probably it's really difficult to produce. They worked also on an aerogel based on graphene, which is lightweight. They didn't give numbers. I find only this image in the internet. Another industry which is now interested in using graphene is the construction industry. We all know that concrete is getting so much energy to produce that we have to think about solutions to use less concrete. So why not reinforce the concrete with, for example, fibers, carbon fibers is one solution, but they also think about to put graphene inside. In that case, it's a university in the US working on that to make it 46% more stiffer and have better mechanical properties. It's called nanographene, what they have produced. What is on the market since last year is some clothings for sport activities. From a company called Calma in Italy. We tried to get that one for the exhibition. Were not successful to do so. They use the conductivity for heat in their clothes to bring hot air from one area of your body to colder parts to have a harmonized temperature everywhere the same. So that's what they have in mind. Other company is called Fallback, also Italy, which came out with a graphene jacket this year to have similar properties, absorbing heat, giving heat up when it's needed over time in cold weathers or when you wear the jacket for sports, for example. What I found out very interesting with that company is another jacket which is not made of graphene, but maybe that's also interesting. They have a jacket that is afterglowing, so you load the textile with a lamp before you are going to run during the night, and then you make this, and then you are afterglowing, I don't know, some minutes, like 20 minutes or 40, which is good for you to have when you're crossing a street. So back to graphene. This is the first graphene wafer that was produced by IBM in the US 4 years ago. Graphene, because they used graphene because it has a better electronic conductivity than silicon, and probably we will have better computer systems by using graphene in the near future. 10,000 times better than other graphene ICs up to 2014. I haven't heard about the development they did in the last years, but we have an institute, a Fraunhofer Institute in Dresden working on that too. They were able to be one of the first producers of OLEDs made of graphene, transparent all OLEDs, by the way, because the electrodes are made of one layer of graphene, 0.3 nanometers thick. Last year it was. So they use a wafer made of copper, then they put carbon on top of this copper layer put the copper into an oven, then it reacts somehow under vacuum with methane, and probably they were able to have a single layer of graphene left on a, how do you say, a tape which you, a sticky tape? No, it's not the right, something like you normally use at 3M, by the way. Similar things. So the idea is, for example, to have also graphene used in wearables, wearable devices, on your bracelet, on your arm, a watch, whatever, which is flexible in a way. That could be something for the future. Manchester University is working on that. In 2017, Samsung came up with the first flexible OLED displays. So that is on the market. And they have shown their fold phone, or presented it last week, 2 days after the Chinese did. But they didn't show the real product. They just show something in the dark. Our concept of, I don't know, maybe it's there within the next month, but they were, so the Chinese were faster. And they say you could have the foldable phone by a price of 1,200, I think it was dollars, so 1,000 euros maybe. Samsung is also working on batteries with 45% higher capacity than what we have now on the market. Probably this is also the future for the batteries we are going to use in electric vehicles. That's maybe something that Calmas have to think about, working with Volvo, I don't know. But that is something really interesting. They have showed that in November last year. And they say that they can upload a smartphone 5 times faster than with the normal solutions. Then again, a Chinese company were able to show a charger, a battery charger made of graphene, which was able to load up a smartphone within 15 minutes. That's quite quick, I would like to say. That was presented as a real product on a fair. I think it was in Asia somewhere. But other researchers are still into details about understanding how graphene works. And it's just, we say, okay, it's one layer of carbon, but it has some waves in it, so it doesn't look like a flat carpet. It's more like the ocean with some waves that can occur. And University of Arkansas is working on an idea of why not using these waves, producing energy with the free electrons that can move up to an electrode, which is a negative pole and a positive pole on the other side. So there is a video inside, you can find it on the internet, showing the concept of a wave that is going like that when you're moving and jumping, like a vibration energy harvesting solution. So they work on that. This is the guy, I forgot the name, but he showed, he wrote a report about his research results, and he was able to get 10 microwatts from an area of 10 by 10 microns, just a pure graphene layer. So when you scale this up, that's quite a lot energy you can get from that. Another company or researchers in the US work on a speaker based on graphene, with the idea not to use the vibration, but maybe the conductivity of graphene, that you can create heated and heat zones around, heated air around the graphene and colder air, so that you can have vibration in that air around the graphene. So that's maybe a concept about a speaker for the future. It's called Graphene 3D Lab, by the way, from New York. Graphene sensors could be used, for example, to have a camera that can have 3D images, which is now only possible to get when you have more than 2 cameras. You need 3 normally. When you scan a person, you need more than just 1 camera. And with graphene, it's maybe possible to have 3D images and 3D films made with just using 1 camera. Then why not having the graphene just 1 layer in between glass to use it as a sensor to understand motions? Maybe a thief tries to go into your house, and then the sensor reacts on movement, and you can easily know if there's someone coming near to your building. Another research group in Germany from Leibniz Institute in Dresden works on using the graphene as a sensor to measure the structural integrity of buildings, showing if there are some breaks or fractures in the material which you use, probably for old bridges, interesting, or high rises. Sensors used in the bio area to analyze food, for example, if it's too old or if it's too green or too whatever bacteria on top of it. So that's what Korean researchers are now working on. Nokia, by the way, is working on virtual reality gloves, touch-sensitive things that work with graphene. Then why not using graphene when it's so conductive for heat as a fire alarm system in wallpapers? That's a project researchers did in Shanghai. So they integrate the graphene layer into the wallpaper and then let sensor systems analyze the temperature. Or why not easily use a whole wallpaper as a heating system? That's what is on the market right now. I don't think that it's just graphene. Maybe it's a combination of graphene and graphite. So you just put the paint on the wallpaper and use it as the heating. So the wall could be warm, like what we have on our display by textiles. It could be heated. We found filaments, conductive filaments for 3D printing. They say it's graphene inside. Similar thing, I don't think. I think it's just more than 1 layer, so it's graphite, but they call it graphene because it's, I don't know, more high-tech. Then we found this graphene-based RFID tags that are printed to, for example, have an easier way for ticketing, for example, for fairs or other bigger events. The Graphene 3D Lab is using conductive filament, or there's a mistake to use it, for example, for medical reasons or movements or whatever. Then we found this, University of Glasgow. They have created an artificial skin with solar cells to create energy or to get energy from, and use graphene in the textile to bring the electricity from the solar cells to the system that works to move the robot arm in a certain way. And that's the last example. I don't know exactly how this works, but obviously it's also possible to use graphene as a filter system to get oil out of air or out of the water after a tank or a ship's broken in on water in the ocean. So that's something for the environment. Thanks a lot for the attention. If you have any questions, I try to answer, but thank you.
This is my impression of graphene as well. It's like this multi-purpose material. We don't really know what's going on, but it's really exciting stuff.
Yeah, it is. It's still quite expensive to produce. That's probably the reason why we didn't get the bicycle, because probably it doesn't exist just one.
But do you know how it is produced? You know, this one small layer of carbon.
That is their secret. That's always the thing. How do you get one layer and bring this one layer not to be again back to be together with another layer? What is the natural way of atoms do in nature? So that's why graphite is that's common, but just one single layer to get is really something
so
different.
that was very interesting. I didn't know this. So because I heard someplace that a pencil that has graphite, that is basically graphene, but in many layers.
Yeah.
Do you know, is that correct?
It is.
So
it is.
So
graphene is one layer of the graphite system. Yeah.
But what would you say is the most interesting aspects of graphene when you sort of dug into it? Where did you feel like, oh, this has great potential?
I see the battery systems.
The
battery systems for mobiles and for, I don't know if it's big enough to use in cars, but we have to think about how can we keep the automotive industry in Europe, because we don't have lithium. So that's the core technology for electric cars in future. That's why the German car industry didn't transform into that new technology. That's the reason why. Lithium, they have a lot of lithium in China, but we don't have it in Europe. So up to now, we didn't find an alternative for that battery system, but probably graphene is. But they have to work hard to make it the costs going down to produce it. But it's possible. It is possible.
I mean, I think it's coming. Do we have any questions from the audience? No. I mentioned that before that Chalmers University, they have a huge program on EU level. I'm a bit uncertain what they're sort of looking at, but I think there's a lot of I know there's a lot of research going in, but the way I see it is that we don't really have an industry in Sweden that can absorb graphene. Yeah. So, which industries do you think will benefit from graphene the most in the sort of closest?
Textile industry, for example. You have all these wearables. Maybe companies from Boras could use it.
True.
Yeah. Then you have the computer industry, which probably is not a part of, or not in Sweden. I don't know exactly. Automotive industry, so Volvo could someone to work with graphene. Yeah, and sports, textile, so in that area, lightweight. But then it's more these carbon nanotubes,
Yeah.
which are probably a little bit cheaper to get. But I haven't heard about that so much.
No.
Yeah.
By the way, the textile you're mentioning is in the Material Connection booth.
Ah, really?
Yeah, there's a graphene textile there.
Ah, I have to go.
Okay, thank you so much, Sascha.
Oh, thank you.